Okay, 1.5 inverse functions. Maybe I should just start out talking like this right away so that you know it's just me. No, I'm just kidding. We have a lot to cover here, so I'm going to try to get through it quickly, but bear with me. Inverse function. Let's say we have a domain and a range. A function f maps from the domain to the range. The inverse maps the opposite direction. Okay, so every element in F, you have an element in F that goes to R, that element goes from R to F with F inverse. Okay, let me show you a table. Okay, so there's a table of xy values for x cubed. Here is the inverse. Remember, that is the same as saying the cube root of x, so those are inverses. And I'm going to do, sorry, let me rewrite that. -1, 0, 1. I'm actually going to expand this. This is actually kind of a poor example. Sorry, okay, that should be 2, and that should be 8. All right, so we have -1, 0, 1, and 2, all the way up to 8 here, because 2 cubed is 8. Now these y values become our x values. And you really see that illustration of the x's. So you have f going 2 to 8, f inverse from 8 to 2. Okay. There's a very formal definition for inverse. So we're going to let f of x have domain D, range R. There is a function g of x with domain R. So notice the switch there. The domains are for g. It's the inverse such that g of f of x equals x for x in the domain, and f of g of x equals x for x from the range, then f of x is invertible. That's a vocab word. The function g of x is the inverse function, vocab, and denoted f inverse of x. All right. Okay, so if I have an example of this, show f of x equal to x minus 18 is in invertible. So first thing, I'm going to first calculate the inverse. So set it equal to y. And then swap. Solve for x. Plus 18 divided by 2. You get y plus 18 divided by 2 equals x. So f inverse is you could also put 1/2 x plus 9 if that's easier. So solve for x and then switch them. So I didn't note that step. You'd switch x and y, and that's what yx becomes over here. All right. This is g of x in the definition. So I need to put this. Okay, so second step is to verify these two items, g of f and f of g. So f of g of x is 2 times half x plus 9 minus 18. Distribute x plus 18 minus 18x. Okay, check. G of f of x. We're going to put 2x minus 18 plus 18 over 2. I put it in this one. Those cancel. 2 divided by 2. Check. Okay. So, get used to explaining yourself, because f of g of x equals x and g of f of x equals x. F of x is invertible. Here's a question. What is the domain of f? Is the real numbers, because it's linear. What's the domain of the inverse of f, or g? Well, it's also linear, so the domain is the real numbers there too. Okay, you know what a function is. We're just going to take that step further and learn about a one-to-one function. Okay, a one-to-one function takes every element of f, or every element of the range, every element of the domain maps to a single element in the range. Okay. So let me give you a not one-to-one real quick. See how they both go to the same element? That can't happen. This is a function because every x has its own y, has one y value, but it's not a one-to-one function because not every x has its own y. Okay. There is a standard, a little bit more heady definition on page 35 if you wish to look at it. Okay. Okay. The neat thing about one-to-one functions okay. So if I write the inverse function exists if it's IFF, it means if and only if. If and only if the function is one-to-one on its domain D. Okay. Now you can have an inverse, yes, even if this is not true. There could be an inverse, but it's not going to be a function. Okay. For the inverse to be a function, it has to be one-to-one. Okay. I think the rest you probably can handle. You're basically determining if functions have inverses, what those inverses are, and if it's one-to-one. Okay. One thing you do need to be aware of, if I have f of x equals x squared, the graph looks like that. Okay. F inverse we'll put it in green. Looks like that. That is not function, right? Because this is not one-to-one, right? So if I take the y value 1, it has two x values with it. That makes it it's not one-to-one. It does not pass the horizontal line test. Okay, so if it passes a horizontal line test, its inverse is a function. Okay. So the inverse is not a function because the function does not pass the horizontal line test. Or this doesn't pass the vertical line test. Okay. But here's what we can do. That needs to be open. We can restrict the domain so that all we have is that function. The inverse simply looks like that. This is fun. This is fun. Because this is one-to-one. Okay. Therefore, this has to be a function. Both pass the vertical and the horizontal line tests. We can go both directions. Okay.
Just a short note on the inverse trig functions. Basically, you're looking at the opposite. So if the sine of pi over 4 is root 2 over 2, we know that pi over 4 equals the sine inverse of root 2 over 2. That's 45 degrees. Remember to memorize those. The graphs of these, of course, -1 to 1, 0 to 2 pi, period. The graphs of the inverses, (1 to -1). Let's go 2 pi here. Starts in the positives. It goes up the y-axis. Okay. Basically, what you need to know is how to go back and forth with these. Okay. I'm going to put 1.5's work on here. The bell just rang, of course. Bring questions.
The following students need to come to the office: Nicholas Wells, Damian Behill, Nicholas Robertson, Colton Rebel, Jared Carminer, Andrew Oak, Arizona Hurley, Evan Haas, Jacob Hakewood, Brendan
I have 37 star because I think it's a harder problem.
Bailey, Travis Backus, Allie Duffy.
But you're going to get Tuesday in class to work on this. All right?
Tiger,
Toodles.
Juan Barragon, Carla Pena.